Okay, before I move on to larger systems, let me just show you a couple of results that you might run into with a smaller system. You can actually follow through the steps here and see that what I did here was basically I multiplied this row 1 by a half, and I got 1, negative a half, 2. And then I multiplied this row by 6 and added it to this row to cancel the negative 6. But what happened was when I did that, not only did the negative 6 cancel, but so did everything else. Well, when that happens, we get basically two equations. We get the first equation up here is x minus 1/2 y equals 2. Or, I mean, you can still call it x and y if you want to. I used x1 and x2. But so we get x1 minus 1/2 x2 equals 2. And then the second row just says 0 equals 0. Well, that's identity. So all I have to do is solve this for x1, and I get that x1 actually is dependent upon x2. So what that really tells me is that x1 is equal to 1/2 x2 plus 2. So I can let x2 just be itself, and then x1 is related to x2 in this way. So basically it just means that whatever this second value is, the first value has to be 1/2 of it plus 2. And you can represent that other ways too. You could use t instead of x2, or you could use k. But the point is that whatever letter you use, this is called the parameter, then the other variable is related to it in this fashion. Whatever the parameter is, the other variable is 1/2 of that parameter plus 2. Now, if you go through that process that I just went through, and instead of getting 0 equals 0 on that row, you got 0 equal negative 7, then you're pretty much just done, because you know that's an impossible statement. So we have an inconsistent system, therefore that system has no solution. Okay, now in solving larger systems, if you read my notes, you'll see here that I actually related this to solving a system of equations without matrices, but I'm not going to go through this portion. But basically it shows you, if you solve a system without matrices, how you try to eliminate variables until you can finally eliminate all but one variable, and then you go back and use back substitution to get the other variables. But I'm not going to cover that. You can read that on your own. So again, what I want to talk about is I want to talk about how to solve a system of 3 equations and 3 variables here. Now here's a system, and you know how to put it in augmented matrix form. So it's written as an the augmented matrix is here, and so what we want to do is we would like to be able to convert this to an augmented matrix that has ones down the diagonals and then zeros in these other spots here. So let's take a look at what we can do. Here's the augmented matrix from above there. Okay, so you want to get a 1 in row 1, column 1, which I already have, so we're not going to do anything to that. What we want to do is we want to eliminate this 2. Now in order to eliminate this 2, I have to multiply everything in this row by negative 2 in order to do that. And so let me show you what you get if you multiply everything by negative. So if you multiply everything in row 1 by negative 2, these are the values you get: negative 2, negative 4, 2, and negative 2. And what we're going to do is we're going to add those values to row 2. So here's row 2 right here. So I'm just going to take negative 2 plus 2, which is 0, and I'm going to put the result in row 2, so I'll put the 0 right there. And then I'm going to take negative 4 plus negative 1, which is negative 5, and I'll put that result there. And then 2 plus 1 is 3, and I'll put that there. And then negative 2 plus 6 is 4, and I'll put that there. And there's my 0 that I wanted. Then I also want to get rid of this 1 right here. Now in order to get rid of this 1, I need to multiply row 1 by negative 1, or just minus row 1, or you can say negative 1 row 1, or you can say just minus row 1. So if I multiply everything in row 1 by negative 1, then it just changes all the signs. So I'll have negative 1, negative 2, 1, and negative 1. And then if I add them to row 3, negative 1 plus 1 gives me a 0 here. So I have a 0 there. And then negative 2 plus 3 gives me a 1 here. And then 1 plus negative 2 gives me a negative 1 here. And then negative 1 plus negative 1 gives me a negative 2 here. Now, I want to look at the leading coefficient now in row 2, and I need this to be a 1. So I could multiply by the reciprocal of negative 5 by row 2, but if I take a peek below row 2, I see there's a 1 there. So I can swap these two rows because that won't mess up these zeros since they'll just trade places. So if I swap row 2 with row 3, which is what this tells me I'm going to do, then it will give me this augmented matrix that I have here. Notice that now row 3 is here and row 2 is on the bottom. Okay? Now, this is the 1, and this is what I want to use to eliminate. So I want to eliminate this 2 that's above it and the negative 5 that's below it. So let's do the 2 first. We want to multiply row 2 by a number that will cancel the 2, so that would be negative 2. So we're going to say negative 2 row 2, and we're going to add the result to row 1 and put the result of that operation in row 1. So up here I wrote what you would get if you multiplied row 2 by negative 2. You would get 0, negative 2, positive 2, and 4. And remember, we want to add those values to row 1. So 0 plus 1 is 1, and we want to put them in row 1. So 0 plus 1 is 1, go there. 2 plus negative 2, that's going to be 0. 2 plus negative 1 is going to be 1. And then, of course, 4 plus 1 is going to be 5. Okay, so now I want to get rid of this negative 5 that's below it. So I'm going to multiply everything in row 2 by 5, and I'm going to add that to row 3. So if I multiply row 2 by 5, I get 0, 5, negative 5, negative 10. And if I add those values to row 3, I get 0 plus 0 is 0. I get 5 plus negative 5 is 0. I get negative 5 plus 3 is negative 2. I get negative 10 plus 4 is negative 6. And then after that, I want to change this to a 1 by simply multiplying. I can do that by just multiplying this row by negative 1/2. So of course, if you multiply the zeros by negative 1/2, they're still going to be 0. If you multiply negative 2 by negative 1/2, you're going to get the 1, which is what I wanted. And then if you multiply negative 6 times negative 1/2, you're going to get a 3. So now I want to use this 1 to eliminate the 1 in this row and the negative 1 in this row. Well, to eliminate this 1, I need to multiply everything in row 3 by negative 1. So if you look up here, you'll see this is what I'll get if I multiply everything in row 3 by negative 1. And then I want to add those results to row 1. So I'm going to add the result to row 1 and then put the final result in row 1. So I have 0 plus 1 is 1. I have 0 plus 0 is 0. I have negative 1 plus 1 is 0. And I have negative 3 plus 5 is 2. Okay, now the next thing I want to do is I want to eliminate this -1, and I can actually do that by just adding row 3 to row 2. And since that's all I'm going to do, I'm not going to write what I would get if I multiplied row 3 by 1, because you can just look at it and see that's what you would get. So we're really just going to say row 3 plus row 2. So row 3 plus row 0 plus 0 is 0. 0 plus 1 is 1. 1 plus -1 is 0. And then 3 plus -2 is 1. And now I can read the answer here. X is 2, Y is 1, and Z is 3. So that would be my solution. I just want to mention a couple of other things. I'm going to leave example 2 for you to work through. And so just follow my steps here. And you can see I swapped rows to get a 1 here. And then I multiplied this row by -3 and added this row and -2 and added this row to get the zeros. Then to make this a 1, I multiplied this by 1/10. So actually it says minus, it should say just plus 1/10. So I multiplied by 1/10, and then it gave me this, and then let's see, after I did that, looks like I left a step out, but after I multiplied that by 1/10, I did 3 times row 2 plus row 1, and then I did minus 4 times row 2 plus row 3 to get rid of the 4. And then after that, I had to multiply this row by -5 to change that to a 1. And then after I did that, I had to multiply this row by 1/10 and add it to this row to cancel the -1/10, and then multiply this row by 7/10 and add it to this row to cancel the -7/10. And when I did, I ended up getting x equals 2, or x1 equals 2, x2 equals 0, and x3 equals -1. So that's the solution there. Like I said, I'm sorry about that. I did leave out one step there that should have been between here and here. Here's just an example of a dependent system, how to interpret the solution to a dependent system with a larger matrix. And then there's a practice problem, and there's a couple of word problems here that you can read and see that were set up here. Number 3 is a little bit different. Let me just tell you what's happening on this one real quick. I only have 2 conditions here. I have to have 11 trucks and 31 tons. And so when I reduce that and then get the equations, I just get these 2 equations, x equals 3z plus 2 and y equals minus 4z plus 9. So I know that x and y both depend on z. So x equals this, y equals this. So what I did is I knew that z couldn't be a negative number, and I know that z has to be a whole number. So I just started with the smallest value of z that I could use. I know that the smallest value z could be, since z is a truck, has to be 0. So when I put 0 in for z, I plug it in for x, and I get x is 2. Plug it in here, I get y is 9. Well, then I tried z equal 1. Could we have one truck, one z truck? And turns out we can, because that would give us 5 of the x trucks and 5 of the y trucks and 1 of the z trucks. And then could we have 2? Turns out we can. If we plug 1 into this, we get 8. If we plug 1 into here, we get 1. Actually 2, I mean. We get 1. And then what happens if I go higher than 2? Well, if I plug 3 in here, I get a negative number, which is not possible since we're dealing with trucks. So there's only 3 solutions here. These are the 3 solutions that actually would satisfy the problem. The last thing I want to mention is you can Google this on YouTube and look for how to solve using the RREF key on your calculator. And I gave you an example there that you can do, but you can solve larger systems just using the RREF key on your calculator.